David Smith here with one more flipped classroom math lesson. 3 tips before we start. First, remember that you can adjust the playback speed faster or slower as you desire. Second, you can pause the video at any point to jot down some notes or write down some questions for our next class. Lastly, you could turn on the captions so you can read my words go by on the screen. Today, we're going to review the mathematics in our financial mathematics chapter. So let's get started. What we did first is we just looked at how to quantify, how to calculate percent change. And the key part of that was coming up with the correct multiplier for a percentage increase or a percentage decrease. So let's take a look. A 12% increase. Now, if you remember how to do that, pause the video right now and do the steps. Okay, let's see how you did. For an increase, we always start with 100%. 100% of what the thing is what we have now. So you always start with that. Now this is an increase, so we're going to add 12%. So that's going to be 112%. Okay? Now here's the thing, is that percentages aren't actually decimal numbers. It's a percentage out of 100. So we turn that into a decimal by moving the decimal places 2 over, and this is 1.12. So that is our multiplier. That's how we get a 12% increase. Now check it out. You notice that 12% is right here. If you turn that into a decimal, it's 0.12. So if you add that to 1, which is 100%, you get 1.12. So once you understand how this works, you don't necessarily need to write this multiplier step. You can just go, oh, 12%, that's 0.12, add it to 1, that's 1.12 for my multiplier. Presto. Okay, now let's do a decrease. Here's a 9.5% decrease. Why don't you pause the video, see if you can come up with the correct multiplier. Okay, let's see how you did. That's just going to be 100 minus 9.5%. Now why is it minus? It's a decrease, so we have to subtract. So this is going to be 90.5%. Now as a multiplier, we move the decimal over, so this is going to be 0.905. So that is our multiplier for a 9.5% decrease. And this works the same way if you want the shortcut. 9.5% is just 0.095. So to get the multiplier, we just subtract that from 1, and that's what's going to give us 0.905. Okay, as we worked through several of the different lessons, we dealt with percentage increases, which could be markups. We dealt with percentage decreases, which could be discounts. And we dealt with add-ons like sales tax. And then remember, percentage increase can also be the growth of an investment. Like $1,000 is invested in a bank account at 5% per year. What does it look like at the end of that year? How much is in the account? Or a stock in the stock market that decreases by like 8% over the course of a year. How much is left in that stock account at the end of the year? So we did a lot of percent increase, percent decrease in a whole bunch of different problems. So I'm not going to do all the types, but I'm going to do some. So check this out. This could be like a piece of furniture in a store. $5.50 is what, as the store owner, what I paid for that. Now I can't sell it to you at that price because then I don't make any money. So let's say the markup is 32%. So I'm going to go through this. First is your multiplier. 100 plus 32 gives us 132%, which turns into 1.32 as our multiplier. Now we just take that multiplier, multiply it by 550. 550 times 1.32 equals the price in the store would be $732. Now, I want to give you a quick little piece of advice, because some of you guys can read this question and then write the answer down. You can just pull out your calculator, you know what to put in there, and you can write the answer down. On a test or a quiz, show me that step. If you don't, and you mistype something on your calculator and the answer is wrong, you get no points. If you show me the correct equation, that's half the points right there. So if you get something wrong on your calculator and you get the wrong answer, you give me the opportunity to give you partial credit. So don't ever just show an answer for these kind of problems. Show your plug-in step. Okay, now let's do a discount. Let's say that I'm a store owner, I have this thing, like it's a book. It's $12.50, but it's been on my shelf for a year. It's just not selling, so I'm going to discount it by a hefty amount. I'm going to discount it by 55%. Pretty nice deal. Let's find out how to do that. The multiplier, again, start with 100, but now we subtract our discount, minus 55%. That's going to equal 45%. Now to get that into a multiplier, we move the decimal 2 over, so the multiplier is going to be 0.45. To find out the new price, we just take our $12.50 and we multiply it by 0.45, and that's going to give us do that again. Just take out the calculator, 12.50 times 0.45. That gets us $5.63. So that's the discounted price. Now finally, we did some add-ons. And the typical add-on is a sales tax. So what we're going to do is we're just going to apply this 5% sales tax to these prices that we calculated. Okay? So in this case, we marked up that piece of furniture to $732. Let's say somebody buys it. So now we need to add the sales tax to compute the final total of the sale. So let's take a look at our sales tax. 5%, let's get the multiplier. That's 100 plus 5% equals 105%, which is going to give us a multiplier of 1.05. So now I just multiply 732 by 1.05, and that's going to give us 732 times 1.05. It's going to give us 768.60. 768.60. Now let's do that again, but I want you to pause the video and calculate the total for this one. Okay, same multiplier, same sales tax we used over there, so this is times 1.05. That's going to give us 5.63 times 1.05. That gives us $5.91. So with sales tax out the door, this one is $5.91. So now let's do some chain percent problems. And these problems, it's basically just you have a starting value or an amount of something, value of a house, the amount in an account, and then there's a percent change that happens for the first year, then for the second year, and for the third year. And those percent changes can go up or down. So we're going to do an example with both of those. Here's the general idea. You take that original amount and you multiply it by the first percent change. That gets you the amount after the first period of time, usually 1 year. And then you multiply that new amount by the second percent change, and that gives you the amount after the second period of time, or the second year, and so on. You could do this for 20 years with different changes each of those years. So let's do an example problem. Here's a stock that's valued at $275. Now I'm giving you what happens right here. Year 1 goes up by 13%, year 2 it goes up by 4.5%. So we're great, it's going up. Year 3 it went down by 16%. So let's see what happens to that stock. So our multipliers, I'm just going to skip all the intermediate steps. 13% is 1.13, that's the multiplier. 4.5% is 1.045, that's that multiplier. And 16% is 1.16. Now what I do wrong? Yeah, 16 is down. So that's 100 minus 16. So that's going to be 84. So that ends up being 0.084. So that's the multiplier for a 16% decrease. Okay. Now I skipped a lot of steps there, so you want to pause the video if you don't see that and do the multiplier calculation and make sure you can get to 0.84. Okay, so let's chain this together. It's going to be 275 times our first multiplier, 1.13, times our second multiplier, 1.045, times our last multiplier, 0.84. Running out of room there. Let's see what we get. Actually, make a prediction. And I don't really know. It's going to be close, I think. We went up by 13%. Then we went up by 4.5% more, but now we're going down by 16%. Do you think this investment is going to be worth more than $275 at the end or less? Okay, let's find out. Check this out. 275 times 1.13 times 1.045 times 0.84. What do we get? 272. $272, and what's our change? 78 cents. So that 16% decline definitely took a bite out of our earlier gains. Pretty cool. Okay, before I jump into simple interest, I just want to mention that appreciation and depreciation are just more of those percentage increase problems or percentage decrease problems. I'm not going to do separate examples for them because they run exactly the same as the other ones that we did. But just remember, you need to know what appreciation means. Increase in value. Depreciation is a decrease in value. Okay? All right, so let's look at simple interest. This is where you can give a bank some of your money and they will pay you interest while they have that money. And then they take it and do other things with it while you don't have it. And then if you want it, they'll give it back to you. But meanwhile, they're paying you interest for the use of your money. So let's take a look at this situation. Here's our simple equation. The interest earned on an amount, which would be called principal, that's why it's P, is principal times the interest rate as a decimal times the number of years, which stands for N. Okay, so if this equation is troublesome to you, you want to drill back to the earlier video where we explained this and did a lot of examples. So, the interest, here's our situation. I got $327 at 7.5% for 3 years. How much interest is earned? Remember, this is I. This is not the total amount at the end of the time. It's just the interest. So, this is going to be I is going to equal principal 327 times our interest rate as a decimal. So this is not a decimal, this is a percentage, so that turns into 0.075. That's the decimalized version of that interest rate times 3. Let's see what we get. 327 times 0.075 times 3 equals 73.58. So the interest is $73.58. Now pay attention to the problems because it might ask you how much is in the account at the end of 3 years, in which case you'd have to add the interest earned to the original amount, and that would give you the amount in the account. Okay, simple interest is a nice entry to calculating interest on money, but the truth is that's not how banks pay interest. They do this thing called compound interest. So there's a period of time over which, at the end of which they calculate the interest, they put it in your account, and then the next period of time, that interest you just earned for the last period is now in the account earning interest in the next time period. So your investment will grow faster. So in this example, we use yearly compounding. In fact, in this chapter, that's all we do, but just remember in practice, banks use daily compounding. So let's take a look. $15,000, this could be a savings account, is invested at 9% for 2 years, compounded annually. So because this is 2 years, this is going to be a two-step calculation. The first step of this calculation is to figure out what's in the account at the end of the first year. So what we've got is it's our $15,000. That's what we're starting with. That's our 100% that we start with. Now we multiply it by our multiplier. Now the percent here is 0.09. But remember, the multiplier has to have the 1 in front. So this is 1.09. So that's going to give us the amount of our investment at the end of the first year. 15,000 times 1.09 gives us $16,350. 16,350. Pretty cool. We've made some money. Now, the second year, we start with this amount in the account because it got added at the end of the first year. The interest got added. So now we're going to do 16,350 times, again, 1.09, that's our rate, times 1.09. Now we have 17,821.50. So now our account has grown again. So this is compound interest. The idea here is that at the end of the first year, we got some interest added to our amount. So the second year, it's that new amount that's earning the same 9% interest that gets us all the way up to this amount. Okay, now because compound interest is such a common calculation, we actually have a formula for that, so you don't have to do it step by step by step. Because imagine if you had a situation like this one, maybe for 4 years, you have to do 4 steps to do that calc, or if it was a 20-year investment, you'd have 20 steps, kind of tedious. So we have an equation that lets us do this in kind of one process. So let's review that equation. Future value, FV, that's the future value of an investment that starts with present value, PV. And it's basically just present value times 1 plus the interest rate raised to the n power. N is the number of years, R is the interest rate in decimals. Okay? And then for your order of operations, you've got to remember, once you figure out what 1 plus R is, you have to raise it to the n power before you multiply it by the present value. If you get those out of order, you won't get the right result. Okay, so let's plug this in. I've got $4,600 to invest. I put it in an account that gives me 3.5% interest, and I'm going to leave it in there for 4 years. What's my future value? FV equals. Now pause the video. See if you can get this one all the way done. All right, let's see how you did. 4,600 is my present value. 4,600 times 1 plus, now my interest rate is 3.5%, but that is 0.035 to the 4th power. So FV equals 4,600. I'm going to just simplify this out. Okay, so now I have everything I need to do. I can chain this together in one calculation. I'm going to go 1.035 to the 4th power. That equals this number here, and then I'm going to times that by 4,600, and I'm going to get 5,278.61. 5,278.61. So that's what you have at the end. Now that you've watched the video, jot down some notes, some questions, or a quick summary of the lesson. You can also re-watch the portions of the video that challenged you the first time. If you enjoyed the video, please click like. If you'd like to help me grow my YouTube channel, please click subscribe.